fundamental concept in calculus that help us understand how functions behave as the input values approaches a specific point.
The limit of a function f of x is the value it approaches as the value of x approaches c certain value. As x approaches c, the limit of f of x approaches L. This written in symbols as follows. The limit function f of x as x approaches a is denoted by the limit as x approaches a of f of x is equals to L.
So let's proceed to the next one. K-concepts. K-concepts has 5 parts. First is function. Function is a relation between a set of inputs called the domain and a set of possible outputs called the range. Second, limit. The limit has the value that a function approaches as the input values approach a specific point. Left-hand limit. The limit as the input values approach from the left. Fourth, right-hand limit. The limit as the input values approach from the right. Fifth, two-sided limit. The limit as the input values approach from both sides.
So we're going to find the limit of a function x plus 2 where x approaches to positive 4. So in this case, we are going to use table of values. We have a number line here to where we will see the positive 4. So we have two options to find the limit of function. We will use the values of x from the left side and values of x from the right side. Okay, so let us first find the value of x from the left side, where the values of x can be seen getting closer to positive 4. So the limit of a function x plus 2 where x approaches to 4 from the left side is equal to 6. So the values of x from the right side, in order to find the x, you can use what you want but closer to positive 4. Let's begin in positive 5 going to positive 4. So the limit of a function x plus 2 where x approaches to 4 from the left side is equal to 6 in the right side where the limit of a function x plus 2 where x approaches to 4 equals to 6. So that means they are equal. What we call this is one-sided limits. If our one-sided limits are equal, we can say that the limit of a function x plus 2 where x approaches to 4 is equal to 6. In that case, we will call that two-sided limits.
This is the practical application of limits. First is the drug dosage calculation. Limits can help model how drug dissolves in our bloodstream over time.
The concept of limits from calculus is used in the medical field, particularly when analyzing how medication concentrations change in a patient's body over time, allowing doctors to determine the appropriate dosage and frequency based on the drug's rate of metabolism and absorption.
One is car acceleration. The way a car's speed changes at an instant is determined using limits.
Limits are used in the context of car acceleration, as there is a maximum acceleration a car can achieve due to factors like tire grip, road conditions, and engine power, essentially acting as a limit on how quickly a car can speed up.
The third is structural analysis. Engineers use limits to analyze how a structure responds under load, ensuring safety in bridges and buildings.
The concept of limits is used in structural analysis, specifically within the field of limit analysis, which is a method to determine the collapse load of a structure by analyzing the point where stresses reach their yield limit, essentially using the mathematical concept of limits to find the critical load at failure.